finding ways to win. That is a huge strength of HP. We work with what we find, we listen to you, and there is no my way or the highway attitude at HP. You know, I'm a real-world practical pragmatist. I live in the realm of the possible. But there is another side to Hewlett-Packard, and that's what we're going to focus on today. The side of HP that invents the future. And we've been doing this for a very long time, for 75 years. And so now, let's look into the future together. We have some very dramatic things to share, a game-changing technology, a catalyst for a revolution. And then, today, we're being joined by Tom Friedman, a New York Times columnist and author of The World is Flat, and That Used to Be Us, along with Brian Krasnich, the CEO of Intel, and Satya Nadella, the CEO of Microsoft. And they'll join me in a conversation with Tom about a discussion about innovation and the future of technology. But first, let's start a little closer to home. Let's start what's in your hand, your pocket, the computer or printer on your desk back at the office. There's a revolution going on there too. I said at the very beginning of my tenure as CEO that we will reinvest in innovation. And along the way, I've been reminded that innovation can come from any source, sometimes unexpected sources. And a good example is what's happening in our Printing and Personal Systems organization. We are infusing innovation into everything we do, from supply chain operations to business model innovations to rejuvenating technologies that some dismiss as yesterday's news. But we know better, and we give them new value and new relevance. When you look at the big picture, you see this happening. Seemingly mature products and technologies are achieving new heights in the marketplace. They're pushing into new and uncharted territories, breaking barriers, crossing lines, and poised to go places the naysayers thought they'd never go. Watch this video where Stacy Wolf explains how we take what we learn from consumers to create innovative products that work in the enterprise.
In a blink of an eye, the workforce has completely changed. It's a blending of two worlds, the blending of the consumer world, the blending of the commercial.
What's so unique about Hewlett-Packard is that we're able to cross-fertilize all the time. And I can pull things that are great innovations in quality to the consumer side and the latest, coolest materials and trends from the consumer to the commercial. The commercial customer, probably driven a lot by the millennial, has shifted closer to that consumer audience. They want that transformation from tool to cool, if you will. The perfect example of that balance between commercial and consumer can be seen in our X2 family. It's 2-in-1. It has the functionality of a notebook, but the benefits of a tablet. We have a consumer version and a commercial version. On our commercial products, it's so much about performance, so much about security. We put in a security card slot, so I can actually put my security card in there. I have a fingerprint reader built into the system. The Spectre 13 is a beautiful product. It's a product designed really with thinness in mind. And it's easy to imagine carrying this around. How does that go into the commercial space? We've taken all the, I'll call it design attributes that we've put in the Spectre 13 into our new 1040. But it's added a few more things. We've built a better wireless engine into this device because that business customer demands of it. The Z1 is probably the most powerful all-in-one on the market. But what is really remarkable is we've been able to take that and bring it into a form factor for the consumer. So what I have in front of me here is the NV23. All the power, but it also has the articulation and movement. With the OfficeJet Pro X, we had to rethink how we were going to do ink technology. In the business space, there's a higher demand for great output. This is a page-wide array. It's delivering 70 pages per minute. It's putting down 1 billion ink dots onto a piece of paper through over 42,000 ink nozzles, all within a second. Those are remarkable numbers, and only Hewlett-Packard can do that. We've brought over 400 new products into market this year. These are some of the best products we've ever produced. So whether it be at the office or at home or on the go, we're bringing the best experiences to you.
Visual on the target. Using this intelligence in 3, 2.
As Stacy said, we're bringing the best experience to you, and we are really proud of the work we're doing to continue to lead industry innovation. And what we consistently demonstrate is the increasing symbiosis between the consumer and the commercial sides of our business. Now, you may be wondering what I'm standing next to. This is a new product with the code name Niagara that extends our innovation in consumer and SMB technologies to fundamentally change large format printing. We use the code name Niagara because the way the paper cascades from the device is reminiscent of a waterfall. There are many companies that need to print large format documents, and today the market offers 2 alternatives to do this: LED or inkjet. And in many cases, you end up having one of each sitting next to each other. HP's page-wide technology solves this dilemma. You can print color at breakthrough printing speeds, and it's cheaper on a cost per page basis than the most productive black and white LEDs in the market. So for those of you who aren't printing experts, and I suspect that describes most of you, I assure you this is impressive stuff, and this is something that only HP can do. So, great job to the printer. But now what I want to do is talk about another profound change that's underway. We've been leveraging the same fundamental computing architecture for 60 years. We've moved from the mainframe era to PCs to the cloud, but we've relied throughout on the same basic design. Now, we are amid a data explosion that stands to inundate the current paradigm, and sooner than we might think. Remember yesterday, we talked about rising data volume, how it is increasing exponentially. Cloud computing, the Internet of Things, mobile networks, machine-to-machine computing, all generate more and more data and set it in motion. Movement takes time and energy. You can't walk across a room without burning time and calories. The same goes for sending a megabit across the room. 90% of the time and energy consumed by a current generation computer goes to moving information from one tier of memory to another via copper wire. If you recall, copper is the same element that Bell used to telephone Watson way back in 1876. And this movement takes time, it creates heat, and it consumes power. These foundational technologies do not have infinite capabilities, and we're running out of room. But HP has a vision for what's next. Not a new iteration of what we know, a new paradigm, pure and simple. And when we move to a new paradigm, new things become possible. What kinds of things? Suppose you had a dashboard capable of displaying every aspect of your enterprise operations in real time. You probably have some view of your enterprise today, but by the time you analyze that data and turn it into insights, it's stale. What if we could fix that? Better yet, what if this resource was something you could mine yourself without having to make an IT request? What if you could analyze 1 trillion customer relationship management records in the blink of an eye? Or expand by 10-fold the bandwidth and storage of all your data centers without having to build your own power station to support them? And look beyond your own organization. Wouldn't it be great if your doctor could compare your symptoms and genomics with those of every other patient around the world to instantly improve your health without language barriers and privacy breaches? All of these things will be possible with something that we call the machine. HP is building a new way to compute from the ground up. We've been talking about many of the component technologies for some time. Now we're bringing them together in a single project to make a revolutionary new compute architecture available by the end of the decade. This changes everything. The machine is not a server or a laptop or a mainframe. It's a continuum. It is all those things and more, a new approach to managing the distributed information landscape. And here to tell us more about the machine is HP's Chief Technology Officer and Head of HP Labs, Martin Fink. Martin.
Thank you, Meg. That's a great setup, and welcome and good afternoon to everyone. I hope you're enjoying Discover. I have to say I've had the opportunity to sit in the audience and watch these big screens, and it's kind of new at Discover this year. They have this thing which is that long one where the speaker gets followed around, and I have to confess that I have this uncontrollable urge to run across the screen and see across the stage and see if the cameraman can keep up. And notice also I'm allowed to talk about things that are very tall but not very wide, right? So I'm going to be constrained in what I can go through. So Meg talked about actually a number of themes that hopefully you've heard throughout Discover, right? And so some of those themes are energy and the need for us to do computing differently because we are going to run out of energy if we keep doing the same way. The second one is density. You've probably heard now with the Apollo launch that a lot of the conversations that we have are around getting more compute density. And the third major theme is this notion of this insatiable ability that we have to create data in all of its forms. And so those are the themes that are causing us to rethink the way we've been doing computing for such a long time. So if you think about it as an IT industry, whether it's your phone, your laptop, your server, we've actually been doing computing and using the same computing architecture, and we've been doing it the same way for decades. We have general purpose processors. We have copper connections that connect the processors to multiple tiers of memory and storage. And on top of that, and early in the 2000s, when we created virtualization, we actually recreated that architecture completely in software. And so what we're doing here is giving you a peek behind the curtain of HP Labs to show you an ambitious research project to rethink how we do computing from the ground up. Now, it turns out HP Labs is actually no stranger to big projects. And in fact, the last time we did something probably on this order was in the mid-'80s when we reinvented computing then with RISC-based chips. At the time, that RISC project was codenamed Spectrum, and the very first server was called Indigo. I actually joined HP in May of 1985, and I was actually fortunate to be one of the guys who installed some of our very first RISC servers with some of our very, very first customers. So for me, this is really special to be in a place where we can go do this again, and it really is time for the next one. And that's why we've embarked on this project we call the machine. And contrary to what Meg would have you believe, we called it that because HP Labs does not have a marketing department. And we said we'll call it that until somebody comes up with something better, and well, we know how that played out. So let me introduce you to what the machine is, and then we'll go into a little bit of detail. So the machine actually rethinks computing because we're going to now take specialized processors. We're going to specialize the compute to the actual workload that we're running. And I'll actually connect that to some of the work that we're doing today. But the other thing that we're doing is we're going to connect that to a large single pool of what we call universal memory. And again, we'll give you a little bit more details on that. And then we're basically going to just connect those two with a very high-speed, low-latency fabric based on photonics, where we use light for communications. This will enable us to deal with massive, massive data sets. But not just be able to take those massive data sets, but ingest them, store them, and then manipulate them, and do this at orders of magnitude less energy per bit or per compute. So with that summary of the machine, let's start going into a little bit of detail. So the first thing is you actually see on the screen, and my camera friend, come on out, since my day is teasing cameramen, so I'll put this here. So this is a little bit of what you're seeing there as an animation is a mock-up, and to give you a sense of what we're doing in HP Labs. We actually do some of the early mock-ups in order to get a sense for what this thing can do, what this thing can look like. Okay? So before we go into the details of the mock-up, let me actually give you a sense of how much that mock-up can grow. And so let's tie this together. So what you saw here, we can actually scale to the rack. We can actually scale to the data center level. And we can scale incredibly. And you see from this enclosure that we're able to do incredible things here. But the scale and what's important is actually, I have a machine right here. We want you to be able to store your entire life. Think of 100 terabytes on your smartphone. So actually, the truth is, the reason why we called it the machine is exactly what Meg said. It's not just a server, it's not a laptop, it's not a tablet, it's not a phone, it's actually all of those things, okay? And so let's have a look in a little bit more detail on some of the parts that enabled us to do this. So I said we're going to focus on the compute side, where we focus the compute engines on the workload that we're doing. Now the reason why you want to do that is because then you're able to focus that compute so that you're using only the energy that you need for the job that you're running. You're customizing the hardware to change that cost, power, energy curve. And so Moonshot is our first instantiation of that, and we're building on what we've learned with Moonshot and creating system-on-a-chip packages that will combine all of the components I've talked about of the processor, the memory, and the connectivity. The next part, as I mentioned, is photonics. Using light instead of electrons and copper wires for communications is absolutely key to that scalability. What you saw in the earlier animation was 160 racks, but the key is those 160 racks behaving as one server. Any one byte in that rack of 160 petabytes can be addressed in under 250 nanoseconds. Byte addressable, 160 petabytes in under 250 nanoseconds. And we can do this to the very large, and we have line of sight to doing this upwards of a gigabyte of memory. So let me give you another way to kind of visualize how this impacts our design and our thought process. So here is a very standard conventional blade that we sell today. And give you a sense of how computer architectures work today. This is a processor. There's no processor in this hole, but this is actually where a second processor would go. Okay? So for those of you who are not steeped in computer systems architecture, these are the memory chips, right? This is where the memory for your computer, and then there's another set of slots here. Now, what many people actually don't quite understand or know about is this processor is allowed to talk to this memory, this processor can talk to this memory, but in order to kind of cross those lines, they have to start asking permission from each other, and you can see how quickly complicated that gets. The other thing is you'll notice that the memory and the processor are very, very close together. And we don't do that because it's interesting or because we want to have a small form factor and those kinds of things. We actually do that because electrically we have to. We get into weird physics things called signal integrity where you can't actually separate this stuff out. So your design flexibility when you're dealing with the current architectures becomes fairly limited as we've tried to bring all of this density to this architecture. So I'll give you a sense of how we're rethinking how we do this. Here again, I'll start with this, would be a standard processor, okay? See, there's a whole bunch of pins, right? Now I want you to just think for a minute. I just told you that we have a rack, or a set of racks, I should say, where we can actually address, byte address 160 petabytes of data in under 250 nanoseconds. How many pins do you think I need on here in order to make that happen? It kind of doesn't work. It's too hard. It's too complicated. So this is where photonics becomes so important. So this is a piece of fiber. We have line of sight to basically getting to about 6 terabits per second on a piece of fiber. If you tried to do that on copper cables, you'd have a bundle about this big. That's the kind of magnitude. And the energy reduction is in the thousands. And so what we do now is we rethink how we do this by rethinking memory in a cube-like fashion, photonically connected to your processor. So you see how our design constraints have now completely vaporized. We're no longer limited to two-dimensional thinking when we design, whether it's a phone or a laptop or a tablet or a server or a rack of servers. We can actually rethink how we store data and how we connect to that data and make all of that available. Oh, come on, that's cool. Give me something. All right, so I already gave you a hint about a different kind of memory technology. And so the way we want you to now start thinking about this is what we call universal memory, all right? As Meg was saying, the reality is 90% of what a system does or an operating system does is actually shuffle data back and forth between this chain of storage and memory. And we do this obviously because we're trying to balance cost and performance. And actually, the triangle picture that you saw up there is a very simple version. A real system these days can have anywhere from 9 to 11 layers of hierarchy that needs to be managed. In Geekland, we call that the volatility chain. We're basically throwing out the hierarchy to allow all of our massive data sets to come on in and be able to be stored and accessible as universal memory. We're going to take all of the best of DRAM from a performance and byte addressability, combine that with flash-like storage, and we're going to make those things one thing and call it universal memory, and that technology is something we call memristor. All right, so bear with me here because I'm going to ask all of you guys to think back to your past and to high school chemistry. In chemistry, you probably learned about something called ions. And if you don't remember, if you forget that part of your chemistry class, an ion is where you have an atom where you've either added or removed electrons from the outer layer. In our case, we're using oxygen atoms. And we remove 2 electrons, and it becomes an ion. That unbalance in profile that we've created is what allows us to now store data at the atomic level instead of using electrons. And so we can now do this on a much, much greater scale. We can flip between 0 and 1 at the picosecond range, and we require no energy, just like flash, to maintain the state over time. Again, tremendous increase in density, tremendous reduction in power. Now the cool thing is when you start thinking about, my God, I've got now a system or a data center with 160 petabytes of byte addressable non-volatile memory, I'm still going to have to manage all of that information. And this is where the connection to 3-PAR is so critically important to us. The announcements that the 3-PAR team made this week with our all-flash array is absolutely phenomenal. But it connects a dot for you, because a big part of what that technology that comes with that flash array is all about provisioning that data, managing that data, tiering that data, and you're going to need to do this in this world. So the good news is all of the investments that you make today in your 3-PAR technology is actually all being conceived of and included in where we are going in a universal memory world with the machine. So let me simplify all of this and make you think about this in 6 simple words. The machine is this: electrons compute, photons communicate, and ions store. This is why you had to come to chemistry class with me, otherwise this slide made no sense. Okay? But if you just remember those 6 words, you will actually understand what the machine brings to the table. Electrons compute, photons communicate, ions store. But you know, the reality is doing hardware and not thinking about the software is actually not really all that helpful. We actually have to think about the software stack and what happens to the software when you now have this vast amount of non-volatile memory that is directly available to you. And you know, we started to think about this and said, what does an operating system do today? Well, it's kind of what I said earlier. It's kind of what Meg mentioned. An operating system spends the vast majority of its time moving data between storage and memory. And so we took a step back and we said, you know, we're probably due for a rethink. And so we are, as part of the machine, announcing our intent to build a new operating system, all open source, from the ground up, optimized for non-volatile memory systems. We want to reignite in all of our universities around the world operating system research, which we think has been dormant or stagnant for decades. Okay, that one's pretty good too, guys. Give me. But wait, there's more. We're not just going to do a clean sheet operating system. That's a huge, huge body of work. And we have to start now to get to something that's going to take a fair bit of time to do. But we think we're going to get a lot. And if any of the conversations I've had with partners, with customers, are any indication, people want to come along with us for that ride. But I can't wait to have the conversation with our university partners around the world, because I think we have the opportunity to really reignite something that really has been dormant. But we're not just going to do that. We also, in parallel, have a team that is starting from a Linux environment and stripping out all the bits we don't need. So that way you maintain that POSIX compatibility layer for your apps, and then we do something different. See, by the way, this is the cool part of being in a research group like HP Labs, is we get to experiment. But wait, there's more. Now you're getting the hang of this, right? Remember this? Remember this? What do you think? What if you think if we actually built a version of Android that was tuned and optimized for non-volatile memory systems? We have a team that's doing that too. So I want you to understand that we are doing this across the board. And we also want to work with any other partners with operating systems so that we can join that non-volatile memory. They can join the non-volatile memory revolution along with us. You know, the other thing as you start getting above the operating system is you have to think about the rest of the stack. And by the way, I'm just not sure if I mentioned it. So this operating system we're creating from the ground up, all open source, so we want everybody to come play with us, right? And so everybody needs to understand that open is at the core of what we do, right? And to bring that point home, right, we announced with our Helion OpenStack all open source. We actually just did a roll today of the next release, but all free, all open source. By far and away, my opinion of the coolest project here at Discover is something called Trifodion, which is, again, an open source project to redefine the world of transactions built on top of Hadoop. If you're building a new application and that new application focuses on big data, the odds are you're also going to need transactions as part of that application. We're giving you the tool to have an enterprise-grade, at-scale transaction system, again, all open source. And then, as I said, when you go up the stack, how do you manage something of this size? How do you start thinking about the thousands of cores in the system and the petabytes of memory that you have available? So we have a team of people that is working at how do you manage at scale. And to give you an idea of that, as part of our Helion OpenStack product, we're including a tool from HP Labs called Loom. Loom allows you to manage thousands of servers and 40,000 virtual machines from one simple console. Management at scale. And we will continue to expand that technology to comprehend the scale that we can deliver on the machine. But at the end of the day, what the machine really does is it enables Haven on steroids. All of that big data that Meg was talking about, that Robert talked about yesterday, that is being thrust upon us, whether it's machine to machine, whether it's human data, whether it's business data, we need to be able to ingest all that, but then we want to be able to run the graph analytics to be able to process through all of that. So this is what we get. In our current simulations, we believe we can reach a 6x performance increase by focusing the workload, but doing it at 80 times less energy. So you can imagine why we're so excited when we think about the machine and bringing all of the pieces together. But the non-volatile nature allows us to also rethink the cloud. We think that what happens when we have that much compute power at the endpoint, that when we have the ability to store that much information where it's being collected, that the characteristics of the cloud also change. And you can see here some of the characteristics we think the cloud takes over a period of time. Because the reality is, even with Photonics Link, there is too much data, and you run into too many legal, privacy, and sovereignty and competitive issues to basically bring all of the stuff to one central location. And we call it the distributed mesh. I called it the distributed mesh cloud. My team called it distributed mesh computing, so now we call it DMC, and everybody's happy. And so this is the cloud for the Internet of Things. So let me give you a use case. Today, a 737 in flight keeps about 31 kilobytes of data on a routine flight. 31 kilobytes, almost nothing. The reason for that is because we discard everything we perceive as normal. Not that we know is normal, that we perceive as normal. Now add the multi-petabyte machine and store everything: wind, temperature, the movie that's playing, the state of the shades, you name it, store it all, process it all locally, and then index that in the cloud. And then instantaneously share that with the entire network of other aircrafts in flight. And it doesn't matter if a Southwest plane tries to communicate with a United plane, because we anonymize the data as part of the process, but we're still able to leverage the intelligence that is created by doing that. And we can create very impressive in-memory graphs of everything: the planes, the people, the gates. I have to tell you, a personal annoyance of mine when I fly is when we land at an airport and the pilot says, "Good news, we got here 30 minutes early because of favorable winds. Bad news, we have no gate." Like, how does that happen? Well, it happens because the ability to graph everything, the gates, the people, the planes, etc., is a really, really hard problem. And we're getting part of the way there with some of our Vertica and the rest of our Haven tools. Here's another quick example at a use case, which is smaller, more effective cell towers. The telecommunications industry actually has a vision of 5 million radios. We actually want to extend that concept so that every one of those 5 million radios has a machine built in. We want to move the transform to where the data is created. The amount of data you create every time you use your cell phone is unbelievable, whether it's data or voice. But now we can process, and guess what? By adding the intelligence, the service providers can now start creating new services and enable those almost instantaneously with almost no people involved, and automate the whole process. And so that's why we recently, for example, announced our Open NFV program. NFV stands for Network Function Virtualization, because we see the potential of taking these telecommunication network functions, put that on steroids with 5 million radios, and create something that is just absolutely incredible. So a lot of people ask us, thank you, when does all this happen? When do we, when can we, what's the date, kind of thing, right? So we want to give you a sense of how we're working on this, and that's kind of what you're seeing here on the screen. But a couple of things to note. One is, all of these components are all in development, right? So we have some system-on-a-chip work that's going on. We have actually 2 research efforts in various areas of photonics. We have a large team working on memory storage technology. The great news about the machine is it doesn't have to be a big bang. It's not like we just wake up one day and everything's all there all at once. The beauty of it is that we can create these technologies towards a final goal of creating a fully integrated machine, but deliver so many of these technologies along the way to products that you're seeing today at Discover and some of the future versions of those products. So just like we did with RISC chips in the Spectrum program and the first RISC-based Indigo server, we're leading the way again. It's very real. We are putting a significant investment, and HP really is leading the industry once again, and we hope you will join us for the ride. Thank you, Meg.
Thank you very much. So when we say HP invents the future, this is what we're talking about. And as Martin said, this changes everything. This is how the world will take advantage of the Internet of Things without drowning in a sea of raw data. We believe that the implications of the machine will be dramatic. Energy consumption problems will virtually disappear. More real-time data will be processed into valuable, actionable insight, and we'll be presented with newly accessible information in medicine, in retailing, in transportation, security, you name it. So thanks to Martin and his leadership of HP Labs, our Chief Technology Officer. We're so excited about what you and your team are doing. So congratulations.
Thank you. Thank you, everybody.
So let me shift gears for a moment and talk about partnership. Partnership is one of the great things about our industry. It makes technology better and helps advance our missions. Leaders working together to build an industry and a world that runs efficiently, where communication is effective, where networks are much more resilient, and where technology ultimately enables better lives. That is what we're all about, but we are not alone in this. With us today are two industry leaders and a man whose opinions and knowledge have won him 3 Pulitzer Prizes and numerous other accolades. Soon, Satya Nadella, the CEO of Microsoft, and Brian Krzanich, the CEO of Intel, will join me on stage to share their thoughts on the future of the IT industry. But first, I want everyone to help me give a warm welcome to Tom Friedman, noted New York Times columnist and Pulitzer Prize winner. Tom?
Thank you. Thanks so much. Thanks so much. Meg, thank you very much. It's a treat to be here. To have these 3 tech giants summit together, for me, it's like being at Yalta. You know, I get to interview all these people together. I'm extremely excited. Meg asked me just to say a few words beforehand about kind of update the world is flat and how I look at the world today. And when I think about that challenge, I often think what historians 100 years from now, when they look back at this era, the early part of the 21st century, and they ask what was the most important thing happening in the early 21st century, what will they say? Will they say it was 9/11? Will they say it was the subprime crisis? Will they say it was the breakup of Brad and Jen or the marriage of William and Kate? What will they say? I think what they will say is that in the early 21st century, thanks in part to companies like HP and Microsoft and Intel, something really big happened. And it was the merger of globalization and the IT revolution. They really started to fuse. More and more IT drove more and more globalization, and more globalization drove the diffusion of more and more IT to a tipping point where the world went from connected to hyper-connected. And that's what I think is actually happening now. I think it is a huge inflection point. In fact, I think it is a Gutenberg scale inflection point in terms of how information and knowledge is generated and turned into products and services. We have gone from connected to hyper-connected and from interconnected to interdependent. These are differences of degree that are differences in kind, And they are changing every job, every industry, every institution. We're all feeling it, but no one's really been explaining it to people. You know, someone was alive when Gutenberg invented the printing press. And some monk said to some priest, now that is really cool, okay? You mean I don't have to write all this stuff out longhand anymore? We're just going to stamp it out? Well, you all happen to be alive, I believe, at a similar leap. Only Gutenberg played out over 200 years, and this is playing out over a decade. Now, I know a little bit about this subject because back in 2004, I sat down and wrote a book called The World is Flat, about how the world was getting connected. And the simple thesis of that book was that four things came together right around the year 2000 that basically connected the world at a differentiated scale. And they were first the PC, which allowed individuals for the first time in the history of the world to author their own content in digital form. Words, data, photos, spreadsheets, video, music. Individuals have been authoring their own content ever since cavemen and cavewomen etched on cave walls, but with the PC, they were able to author it in digital form, which meant it could be manipulated suddenly in so many more ways and sent so many more places. That then converged, didn't have to, but it did, with this thing called the internet, which suddenly allowed me not only to author my own content in digital form, but to send it anywhere in the world virtually for free. And that coincided, didn't have to, but it did, with the emergence of workflow software, which allowed me to collaborate on my content with you and your content anywhere we were in the world. And that happened to coincide with the emergence of this thing called search, which allowed us to each search each other's content to massively enhance our collaboration. The simple argument of the world is flat is those four things converged right around the year 2000 and created a platform where more people in more places could suddenly compete, connect, and collaborate on more things with greater efficiency for less money than ever before. Hence, I declared, the world is flat. Had I been a more honest man, I would have actually called the book The World is Flattening, because in fact there were only about 1 billion people on that platform. But I had a sense where this was going, and I didn't think a book called The World is Flattening was going to sell around the world. So I wasn't a more honest man. But it did go the way I thought. And I only realized how much had changed when I sat down in 2011 to write a new book, then about America, called That Used to Be Us. And the first thing I did when I sat down to write the new book, as I've written in that book and said many times, the first thing I did was get the first edition of The World is Flat off my bookshelf, just to remind myself what I had said. I cracked it open to the index. I looked under A, B, C, D, E, F, F, A, F, A, C, F, A, C, E. Facebook wasn't in it. Yeah, when I was running around the world saying the world is flat, we're all connected. Facebook didn't exist. Twitter was still a sound. The cloud was still in the sky. 4G was a parking place. LinkedIn was a prison. For most people, applications were what you sent to college. Big data was a rap star. And Skype was a typographical error. I love doing that. Can I do that again? Okay. All that happened, friends, in just the last 7 years. 7, 8 years. Something really big just happened in the plumbing and the wiring of the world. We've gone from connected to hyper-connected. And it is changing everything. And what I'm really curious to talk about with Meg and Brian and Satya is, holy mackerel, what comes next? What comes in the next 7 years? You know, Andy McAfee and Eric Bryn-Jolson, and I'll end here, in their wonderful new book, The Second Machine Age, they make a really interesting point. Now, you're all probably too young, but I'm 60, and I grew up on the Jetsons. cartoon, The Jetsons. And they make a very important point in their book. George Jetson flew his own flying saucer to work. In other words, the people who created the Jetsons 50 years ago could not imagine what we have right now, which are self-driving cars. They made George Jetson drive his flying saucer. Ladies and gentlemen, what comes next? Meg, Brian, Satya, come on out here.
Well, we have to wait for our television set to come on out. Satya?
Hi, Meg.
Satya, how are you?
Good. We'll see you here in just a minute as we get our little set moved out here. This is like Good Morning America.
That's great.
It's the machine.
The first iteration. Meg, you get in the middle, and Brian, you take the far end, and I'll hop down here.
Okay, good.
Sit by here.
I get to sit next to the pseudo Satya.
So, Meg, this is your major customer event of the year in America.
It is.
Why did you invite these two gentlemen in particular?
Well, first of all, Intel and Microsoft are critical partners of HP. And as I look at what's going to happen in this industry over the next 5 or 10 years, I think partnerships are going to be even more important than they have ever been. That no company is an island. We've got to rely on each other. We've got to trust each other. And we just happen to have 3 new CEOs of these 3 major companies. And so we've really tried to forge a bond. And I said, gosh, it would be so great if you would come and talk to our mutual customers, because virtually everyone in this audience is also a Microsoft customer, also an Intel customer. And I just thought, you know what? We've got a very dynamic relationship. It's time we can set a whole new course and do what we have historically done for the industry.
Have you ever done anything like this before?
I've never, I mean, we've never been, I don't think, the 3 of us together before in any place in a public forum. So it's kind of fun.
Great, great. Brian, let me ask you, and then I'll ask Satya. Why is something like this valuable for you?
You know, I think our industry is built on innovation, but innovation has to be targeted to the customer needs. And this is a great forum for us to meet with our customer, our customers' customers, just the whole ecosystem, and really start to understand, where's the industry headed, where do we need to target our products, where do we need to innovate, how do we support this group better. So that's why I come to an event like this.
Satya, virtually, why are you here?
First of all, thanks for the opportunity. I mean, I think both Meg and Brian expressed it well. The fact that we have these customers who, over the years, in fact, have led to great innovation from all 3 of us, and I think that's what really gives us the energy. But what I'm perhaps most excited about us is the fact that, you know, we have great tradition of having done and made big innovations, but the question is, how are we going to innovate in the future? And that's what customers want, that's what the industry needs, and we have a new agenda for it in between our 3 companies, and that's a pretty exciting time for us.
Well, let's talk a little bit about that new agenda. We hear a lot now about the Internet of Things, including wearables, machine-to-machine communication, sensors. I want to hear from each of you. What is your vision of this Internet of Things? Where do you see the opportunities? Why is it going to be so important?
Well, what's going to happen with the Internet of Things and the explosion of data, as I've described over the last couple of days, the existing way we do compute is not going to scale for the world as we will see it maybe even 2 years from now or 3 years from now. A lot of people think, well, we don't really need to worry about this so much because it'll be 10 years from now. My view is change is happening in our industry much faster than we have seen in many, many years. And so together, I think the 3 of us can do the pioneering work that we've done in the past. The other thing I think that's important here is that it's important for, I'm a big believer in tone from the top. because our executives, our engineers are out in the field every day with customers. We have millions and millions of man hours of joint R&D. And so if we tell our troops we think this is incredibly important for us to work together to be able to harness this next generation of technology, then that will translate down into the field, which is of course where the customers experience us as three companies.
Because what you're saying, Meg, is that this Internet of Things is going to spin off so much data.
Yes.
That unless you have the chips, the software, and the integration that can manage it, both on the energy side and the density side,
yes,
we're not going to be able to get what we need out of it.
Well, I also think, by the way, no one has figured this out completely yet. So the combination of our R&D organizations are actually going to have to break new snow, pioneer entirely new ways of doing things, which is what we've done together for 30 years. But sometimes 30-year marriages, they need a little rejuvenation. We need to sort of, rebond, renew our vows. And I think, when Satya was named, when Brian was named, I'd only been at HP, and we thought, gosh, this is such a great time to reinforce this partnership. And obviously, we all have partnerships in the industry, but our partnership, the three companies, it was the defining partnership, I would say, of the last 30 years.
Brian, talk about the Internet of Things from an Intel point of view. Where do you see the big opportunity for Intel there?
Yeah, I think we should step back a second and I want to give you my view a little bit about the importance of the Internet of Things. And I was thinking about it backstage when you talked about the world was becoming flat, and I guess my view is this makes the world flatter.
Yeah.
If you take a look at today's world, we get pretty excited about what the cell phone and the smartphone and tablets and PCs have done to bring data and information to a much larger population in a much broader sense. I think it's minuscule compared to what will happen over the next 5 to 10 years with the Internet of Things. We probably have a couple billion devices connected today that have some level of data and intelligence. We're talking something on the order of 50 billion devices connected to the Internet probably by the end of this decade. That is going to unleash a huge amount of data, as Meg said, but it offers all kinds of opportunities in ways I don't think, when I think of the Internet of Things and I think of big data, I talk about the known unknowns, the known unknowns. The known unknown. Those are things that you don't know, but you don't know them.
Right.
Like what
would be an example of that?
How many calories a day does a 45-year-old man need in order to not gain weight? You can do that. You can gather all kinds of big data. But there's unknown unknowns. The unknown unknowns will be truly earth-shattering to us. That's where we'll learn the connected things in our world that we never understood. And if you ask me to give you an example, I can't because they're unknown. Sure. That's the best thing about coming up with a theorem like this, right? I don't have to explain it to you. But these things that are connected, when all of these data points come in and we find that some material in our lives is causing great harm to people that we never knew, or that there's ways to solve problems that we didn't even understand were connected to other devices. Those are the unknown unknowns that will change the way we think about the world. So I think that's the real value. Why am I passionate about the Internet of Things? Is because we can solve real problems as we pool this data together. And these things could be healthcare, industry, all kinds of places.
So for a company like Intel, what is the challenge and what is your signature contribution to
So for us, it's pretty simple. We have a strategy that just takes it down to its root. And that is, we want to make everything smart. So we are trying to define silicon that can go into almost any device or item that you can think of that can raise the intelligence level, because you have to have those sensors and then some level of intelligence to get that data back into the rest of the world. That then allows Satya's operating system and cloud systems to manage that, and Meg's PCs and hardware and servers to go do something with it. But our job, we think, is to go out there and power and make everything you can think of smart. Your shirt, your refrigerator, your car, all the way up the chain.
Interesting. Satya, talk about it from a Microsoft point of view. Where is the excitement and opportunity for you?
You know, you said it right when you said the world is getting flat and it's hyper-connected. And so to me, it's more the Internet of everything.
Right.
It's not a thing. And what is ubiquitous is compute power. And what is scarce is human attention. And so how does one bring, in fact, innovation in the silicon, in the hardware systems, as well as in software, to make, I would say, build this next era of what I describe as the more personal computing era. And if you think about it, right, the era we live in is you walk into any conference room or in your living room, it's not one computing device anymore. It's a world where you have sensors, you have a phone, you have a tablet, you have a big screen, so you have many devices. All of these devices are generating lots and lots of data that rendezvous in the cloud in many cases. You want to be able to reason in the cloud on all that data to improve the very experiences all of these sensors and devices are creating. So to me, making all of that more human, more personal, is the next frontier in this hyper-connected Internet of Everything world. And that's a pretty exciting agenda for three of us who were there when we created the PC revolution and the client-server revolution, to be able to bring all our assets together to birth this new era of more personal computing, I think is an exciting time.
Well, Meg, you don't just have customers out here, you have parents. Mm-hmm. And if this is as big as you think it is and I think it is, it seems to me it's going to require different kind of education, different kind of way of looking at the world, different kind of development of employees. How do you see that at HP?
So I think this may be one of those pivotal moments in history where your hiring, talent acquisition, and training and enabling and empowering the next generation of executives may be very different than the way we grew up in our companies. And what I see in this next generation, and by the way, it is global. It is not just here in the United States in Silicon Valley or Redmond, it is global. How do you harness this talent that may be distributed to solve these big problems in very collaborative environments where you're not co-located? And so how you identify those individuals, how you train them, how you enable them to be successful, I think is quite different. And I will say my view is that this next generation has very different expectations of working for a company. Our strategy is how do you keep these guys from getting bored really fast? And you've got to keep challenges and challenges and challenges. And at least in Silicon Valley, where Brian and I live, employees can move immediately. And so this notion of how do you identify that top talent, how do you keep them challenged? Because this generation, even more than ours, wants to make an impact on the world. I think we did. They really do. It is co-equal to almost all the other rewards in the system.
Brian, when you sit down with the head of HR at Intel now, and you think this is the big challenge going forward, this is going to be huge, as you say, connecting billions and billions of devices and requiring a different kind of engineering and analytical talent. What are you looking for now differently in terms of who you hire?
A lot of what Meg said absolutely holds true, I think probably for all three of our companies. For Intel specifically, though, we're starting to look for people who can really think outside the box. Because what we're having to do as you start to think about these devices that you're going to want to wear on you and maybe wear for days at a time, and then you don't want to be charging them every night and things like that. You need to start working in threshold voltages, basically power levels that are barely on. And that requires people to think outside the box. We're talking about devices that can charge through your body temperature differences, and just again thinking well outside the box of the typical, there's a battery and a charging plug. And those are different kinds of people. When I look at some of the people we're hiring now, we're hiring people who are much more design-oriented and focused on the usage model. The last thing is security. I think as these devices become so connected, you asked, what about being a parent, right?
Yeah.
you know, when you talk about those 50 billion devices, you know, the amount of data that's going to flow off you as a person is going to be many-fold. And Martin did a good job talking about how you anonymize data. We're going to have to let people opt in or opt out for sharing their data, opt in or opt out on whether it's anonymized or not, how it's connected to their other data. So those are different sets of problems that the classical silicon engineer that would be maybe at a company like ours isn't set up to go solve. And we have to work with, as an industry really, on how to go do that.
I'm particularly sensitive to that challenge. I think it's going to become more important. I read, because I follow the Middle East, I read the Israeli newspaper Haaretz every day. And one day I went and bought some golf clubs online. And the next day I picked up Haaretz online, and there was a big ad for golf lessons in the middle of Haaretz. And I thought, I didn't know so many Israelis played golf.
Yeah, that's amazing.
And it's amazing.
Middle of the desert there.
Just amazing suddenly. And I think that privacy issue is going to be critical. Satya, talk about all these and more, which is to say, who are you hiring now? Who are you looking for at Microsoft? How is it different? And speak to this privacy issue in particular when we're amassing so much data, both all of your companies individually and collectively.
Yeah, I mean, in terms of the talent that is coming into Microsoft and the talent that we need to thrive in the future, I would say the new currency to me is interdisciplinary in the sense that you can't just think of it as just a software problem. If you look at even the way a lot of what we build now in, say, machine learning, because one of the areas that I'm very excited about is innovation in this deep learning as a technique to solve some of the oldest problems. So we have a new project around Skype translation, which allows us to be able to break one of the oldest barriers that humans have had, which is language in real time. So you could be speaking German and I could be speaking English, and we could be speaking in real time without an interpreter. Now, one of the fascinating things is it's, of course, a neural network that is really has emergent behavior. But to understand it and reason about it, you might, in fact, need a neuroscientist who knows even how the neocortex works. So to me, having that capability from design to economics to neuroscience brought together with software is what's, I think, getting us to really go after new innovation. So we have lots of those disciplines now represented as first-class disciplines inside the company. And you can't just do pricing anymore without really understanding economics in a pretty deep way, and it has to be built into the product. It's not something that's done on a price sheet. So that's kind of the interdisciplinary nature of the workforce. As far as privacy, I think the most important issue for us as an industry is to get privacy right if we want to be more personalized. Because if you really want to have the birth of the more personal computing era, you need to have real assurance on privacy. That means you have to have a monetization model that can't be just a single solution to everything. Because I think if advertising was the only business model, then you have one stance on privacy. But if you believe the user is in control and they define how effectively they auction off their attention, then you have a different way to think about privacy. And I think that the world and the tech industry has to come together to define it. Otherwise, we won't be able to have that friction-free adoption of a more personal computing era.
There was a very big primary election yesterday in Virginia. The #2 leader in the House of Representatives, Eric Cantor, was defeated. And if you read the stories today, the key reason he went down was immigration. And if you read deeper down into those stories, immigration reform, i.e. H-1B visas, is off the table not only till the midterms, but it just may be off the table right now. If there is one thing Washington could do to aid this huge revolution you're talking about, and immigration is off the table. Is there anything left for them? Is Washington in any way relevant to this incredible opportunity our leading companies are about to seize?
So I bet the three of us have a very common point of view on this, and it is central to our industry, and I would say it goes beyond our industry. It goes to the very economic vibrancy of the United States of America. That if we do not solve this H-1B visa problem, and as everyone in this room knows, every 6 or 7 months they release a certain number, very small number of H-1B visas. They sell out like it's a Madonna concert. I mean, you have got to be in line, you've got to have the right people in the right place to get your fair share. And by the way, estimates are in Silicon Valley we could use 3 or 4 times as many as we are allocated, and I'm sure that's true for Microsoft as well. So we have got to tackle this. We've got to pull the full weight of our industry, because this is not just about the technology companies that you think about. Every company is a technology company. Caterpillar Tractor is a technology company. Every bank is a technology company. And so if we are going to capture this next revolution, which I think is as big as we have seen in our lifetime, we are not going to do this without an enlightened immigration policy. And, oh, by the way, an enlightened change in our education system. Because our K-12 education system was designed for another era. It was designed as the 1800s turned into the 1900s, and we were preparing people to graduate from high school and then potentially go work in a factory. The jobs that are going to be the well-paying jobs have nothing to do with how we are educating kids today, and we've got to move fast to a blended learning model that captures what Brian was talking about. How do you creatively problem solve as opposed to work through your workbook, you know, problems number 1 through 10. So Washington, and I, as you probably know, I ran for governor of California, and I have an understanding now of what government must do to set the table for us to be successful. They will not make us successful. We can't count on that, but there is a table that needs to be set in a very, very competitive world. And I have to say, I think some other countries are thinking a lot more and getting a lot more done in how that table is set.
Well, our strength has always been our public-private partnership. And Brian, how do you see that from an Intel point of view, other than H-1Bs, which is obvious? And
I was going to say, it's so well said. It's hard to follow Meg on a topic like this. But so you're saying, what else? If we can't get H-1Bs, which, by the way, I just want to make one kind of pragmatic. I'm probably not as eloquent as Meg in this, but I look at it as saying, you know, these people that we're trying to hire are smart. They're going to go invent somewhere. Why not have them inventing at American companies for products made in America or produced or generating revenue in America? So I think you have to just at some point take a pragmatic view that these are smart people that we're trying to hire, and they're going to go do things. And we'd rather have them do them here, I think. But if we take that off the table, because I want to make sure we really answer your question, you know, I'll take the next easy one for Washington, tax reform. You know, our process of R&D tax credits, which companies, the three of us, you know, you saw what Martin was talking about there. He's talking about things he's probably been working on for 10 years, and they're still 5 years out. Right. So he's been making investments, HP has, and I'm just going to use them as an example since we're here today. That's a 15-year investment. Right. You cannot make those kinds of investments when you're telling the shareholders, well, I hope there's a tax reform, or, you know, tax credit next year for R&D. Right. These investments we're making are years out. Everything we do, same thing, 10 years out. Satya, same thing. I'm sure he's 5 to 10 years out. Just tax reform on the simple thing like R&D would be a huge impact to the American economy, I believe. And you could go well beyond that in tax reform if you wanted. You know, we have one of the highest corporate tax rates in the world, and so on and so forth. But let's just keep it simple. R&D tax credits. That would be great.
Satya, how do you see it? When you sit down with your senators and congressmen, other than H-1Bs, which is obvious, what else is on the table?
Yeah, no, for sure. I'm a beneficiary of that enlightened immigration policy, so I did.
We're the beneficiary too.
But you know, there are a lot of other issues. I think, first of all, I think the government's role in this area is pretty critical. The one thing that comes to mind for me, which is top of mind, in fact, is the reform of the surveillance regime. Because I think that if you think about it, what's the fundamental role of the government? It is to be able to create trust, trust with its citizens, trust between nations. And so at this point, I think that in particular the United States has to take a real approach where we regain that trust. Because if you think about Intel, HP, and Microsoft, we're global companies, and in order for us to be able to thrive in a global world, we need our government to be able to have a policy that, in fact, creates great trust with its own citizens, but also citizens of the world and other nations. And so that's, I think, perhaps next to H-1B, or in the same league as H-1B, and an enlightened immigration and an enlightened education policy, which I think are the true things that are going to keep America competitive. We also want to make sure that the American industry is competitive internationally by making sure that the trust is regained.
Well, post-Snowden, do you believe the government has enacted the kind of reforms that will allow Microsoft to look its global customers in the eye and feel they can trust their data with you?
You know, I think it is being worked on. It's not solved, because unless and until we can bring some modicum of process of law into how governments can discover data that we store, what jurisdiction does the US government have over customers' data, which is not in fact resident in the United States. These are hard challenges and problems that we now need to bring some amount of stability to. They can't be unknowns, because that's what creates the trust issue. Right now, I would say it's a cause of friction. And all you got to do is go outside of the United States and talk to customers. It's top of mind for them. And so we have to be able to solve that.
Meg, how do you feel about that?
One of the things that is so interesting and great about being in our industry is we are breaking new snow. As I said before, we are creating things that did not exist before. Often there are no land-based analogs for what we are trying to bring to market collectively, which means you are also having to create law. You're having to try to influence how laws are made. You're trying to influence how governments view things. And there is a huge education part of this, because most elected officials don't even begin to understand what our companies are trying to do. And so Satya's right. As we enter a whole new age of this massive amount of data, how you gain insights from that data to improve lives, we have to tell our story. Because if we don't, someone else will tell it for us, and we will be set back years and years and years. But this is going to be very interesting, because most of the elected officials I've met want to know about technology. They're hungry to know, but they can't almost envision what it is that we're talking about. So I think there's a tremendous responsibility as we create things that did not exist before. We're simply going to have to spend the time to bring along society with the technology will be ahead of what society will in many ways be able to embrace.
Brian, what's your cut on that?
I think this is a chance for America to lead. You know, I think the issues are global, not a US-only issue. I think we've seen the issue of data privacy and data intrusion across the world. And rather than pointing, you know, this is another case where rather than pointing fingers or, you know, saying it's part of the process that occurs, we have a chance, I think, to lead here. And I think as a result, our government and our industry would be seen on the world as, you know, truly being the leader and truly being open and transparent. So I think if we do kind of what Satya said about talking about, you know, setting the ground rules, setting the guidelines, but don't do it just with ourselves, but open up to the world, make it a global discussion, I think we have a huge opportunity here. So we can change this from a risk to an opportunity if we act quickly and in the right way.
You know, one of the things about being a leader today, and all three of you are now newly minted leaders. You know, Meg, you're the senior of the bunch.
Which is sort of hilarious.
Is that my friend Kurt Carlson, who runs SRI, you know, once we were chatting and he made an observation to me, which I coined as Carlson's Law. And Carlson's Law is in this hyper-connected world, everything top-down is dumb and slow. And everything bottom-up is smart but chaotic. And the job of a leader now is not to disappear. I've seen that in the Arab Spring, what happened when there's no leader. But it is to move down, as it were, a little closer, because you still need someone who has a vision of the whole field, can see where we need to go, and there still needs to be an editing function of all these ideas coming up. Do you think you are leading, or required to lead your companies in a very different way, if not from your immediate predecessor, but from your predecessor's predecessor in this hyper-connected world? Meg?
So the answer to that is yes. And I think it relates to how you think about innovation. That there are, in my view, two kinds of innovation. There is the evolutionary innovation, which we have to do every day. How does Brian make his processors that much more effective? How do our servers and our converged infrastructure do something incrementally better? The same is true at Microsoft, and we have to be really good at that. The management of that process is very different, in my view, than the management of completely disruptive, what I call revolutionary innovation. And revolutionary innovation is far more serendipitous than many people would actually like to believe. I love to use the example of our inkjet printer. This was invented by two engineers in HP Labs in 1984, and the inkjet printer business had absolutely nothing to do with what HP was doing in 1984. Huh. And so it was complete greenfields. And so if we don't allow enough freedom for the completely non-linear innovation, we will lose the greatness of what made this company great. And so the balance of the financial performance, managing evolutionary innovation, managing the global sprawl of our companies, quite frankly, and how we create that disruptive innovation, I don't think anyone has the answer to that. We are trying to bring that back in HP in a way that we haven't seen in a number of years. And HP Labs has to lead the way there, but it's not HP Labs because innovation can come from any corner at any time. And what we've found to be very effective is co-innovation with partners. We do a tremendous amount of work together. 1 + 1 + 1 often equals 5 or 6. And frankly, when we combine with a customer or two, often you have magic. But if you're not careful, it can lead nowhere. You get no traction, and it's a complete waste of time.
Brian, how about you? How is it different to lead Intel today?
I'd say there's a couple of things. One is the systems have become so complex. We used to be able to just make some silicon, make sure we'd make 3 chips, make sure it was Windows compatible, send them out to everybody, and they would start building systems. And that's really not the way it works anymore. It's now down to 1 or 2 chips. The integration with the software is much tighter. Helping our partners build these systems and understanding exactly what the thermal envelopes are, mechanical envelopes are, what we can do with them, how to integrate their features and differentiation. It becomes a partnership. So at that level, it's become much more complex and much more of a partnership as we bring these products to market. But the other thing I would say is that as we move into these new spaces, you talked about the Internet of Things, you can talk about wearables, you talk about machine learning. I did a review of quantum computing yesterday, very interesting subject of where we're at with that. Somebody once told me that if you're not uncomfortable, you're not taking risk. And so I think one of the other things is the leader, you have to do more and more in this environment. Uh-oh, we just lost Satya for a second. Oh, there he's back. Is you have to move yourself into discomfort. You have to allow those two engineers to try something that you really don't want, or you're not comfortable with, or you're worried, are you spending too much money there?
Or disrupts your existing very big profit streams.
And so I think as a leader, you have to protect. You have to have some areas where you're the protection, because the DNA of the company will try and kind of snuff them out. And so I find I have to go down in, kind of protect some areas, and allow them some time to grow or not. That's a bit different than in the past.
Satya, what's it like at Microsoft?
You know, if you're a large organization, I think Meg said it right, when you have to have different cadence for different types of innovation. And so you need to have that versatility. In fact, one of the things I think about a lot is, what does it mean to have a true North Star in terms of vision, but you're loosely coupled? It's not as if 100,000 people are all working on one thing. In fact, you should feel like a collection of startups, but you're going someplace great, which is something unique to, in our case, about Microsoft. But the best mechanism to ensure that is that every small unit inside of this large company is a learning organization, because the only way a complex system adapts is to learn. And so to have those feedback cycles really engineered so that your customers are informing you, but it's not just the customer's usage today, but it's about predictions of customers' usage tomorrow that you have to pass judgment on. And how do you empower teams, give them the right skills, the tools to be able to do that? And do that in a loosely coupled way so that the entire organism, so to speak, can adapt is, I think, perhaps the challenge for us all.
Are there any changes you've instituted since you've taken over where Microsoft employees would say, there's a new person in charge?
You know, one of the things that I've thought a lot about is this notion that somehow culture needs to be changed, perhaps is the wrong metaphor, in the sense that you don't unfreeze, freeze, because it's, or change and freeze, because that seems that, you know, makes it feel static. So I'm more about saying, look, the data every day is different. What did we learn? In fact, what did we learn from our customers? What did we learn from our mistakes? And are we challenging ourselves? And I think when Brian says, are you uncomfortable? That, I think, is what we should feel every day, because there is a certain amount of judgment and risk every one of us has to take about the future. Because in this business in particular, there is no such thing as, you know, you just do the same thing as you did yesterday and survive. So you have to, by definition, take risk, and to be able to create that environment where people are not risk averse. To me, that's what's at a premium, and so that's what I think Microsoft and any one of us has to do.
Well, it's a good segue to my next question, which is, what is the next big disruption? I know that's nearly impossible to predict, but you've already talked about the Internet of Things. You're already into that. What do you see coming down the pike? Satya, you've spoken about mobile first, a mobile first, cloud first world. Is that the next big disruption? Why don't you kick us off there? What do you see coming next in your wildest imagination?
Yeah, I mean, it's that world of, you know, mobile first, cloud first, but it's that, how do we bring the more human personal computing, or the more personal computing, where my experiences are intelligent and they're not bound to one app on one device. So I walk into a conference room, the big screen recognizes me and the others. It logs us all in. We can whiteboard on the conference room, and when I go back to my device, I have all the notes which have been annotated. There was speech recognition in the meeting. Those are the kinds of things where the intelligence goes with you across all of these devices. And that means, by definition, it's a data-rich world, but it's your ability to sift through lots of data to make sense of it and reason over it. To me, those are some of the advances, I think, that is going to make computing more personal, more human as we go forward.
Satya, let me ask you a question. If there was one thing that you were most excited about, whether it's a new evolution of your fundamental operating system or what, if you could say one thing that you're most excited about, and I'd love to ask Brian as well.
I am really excited about these deep learning techniques as brought together for solving real hard challenges. So for example, when we did that speech recognition technology, it's actually just not speech recognition. We brought together three things that were distinct, which one was obviously recognizing speech. The other one was the ability to do machine translation.
Yep.
And the third was speech synthesis. And you don't simply daisy chain those three, but you in fact build this deep neural net to solve the human language barrier. Now you can apply similar technologies for a lot of other natural interfaces, from image recognition to gestures. So when you take all of that and you say, well, what does personal computing feel like going forward? And I know this is an area that you folks, as well as Brian and others, are really working on. I don't think it's going to be just the mouse and the keyboard alone. Yeah. It's going to be a lot of other input-output breakthroughs. And that's been the fundamental driver of our industry. And I think we're at the precipice of a new set of breakthroughs in there.
Brian, how would you answer that?
Well, there's two questions. One is, what do I think is really going to be the next thing, and then Meg was kind of a more shorter term. I think one of the big short term, especially if I look in the next year or so, is going to be the advancement of, I'm just going to call it 3D in general. 3D is going to come in a variety of ways. You see 3D printing coming pretty quickly. We demoed at CES a tablet that could, you could scan something real time and then send it to a 3D printer. We will have those at Christmas. And in fact, just the other day I was sitting and we were playing in my office and we did a full body scan of myself in about a minute and a half with a tablet and then sent it to a 3D printer. That's going to open up, I mean, almost everybody could become a manufacturer at that point. And I think as we go into next year, that will drive a revolution of innovation that we won't understand. People will come out of the woodwork who can create and develop things that we didn't think we needed, but we do once they do.
What about you, Meg? We're sitting at HP. What do you see as the next really big disruption?
So I think one of the big challenges our industry faces is space and power. And it is not just our industry globally, and I think you've articulated this well. We go from 7 billion people to 9 billion people, where many, many more of those people want the middle-class lifestyle that has been epitomized by the developed world. And the pressure that that puts on power, space, is almost unfathomable. So as much as you maybe get a bit more efficient, then there's more people, and you never actually get ahead. And so we are really, really focused on space and power. And that goes all the way back to the architectural design of the chips, the architectural design of the infrastructure, and then how you're running software on these machines. And we think this is incredibly important to the world, and actually that we are distinctly competent in being able to work with partners like Microsoft and Intel to do things that we must do. Today, just take cloud as, if cloud was a country in terms of energy consumption, it would be the 5th largest country in the world. I mean, think about that. Today, data centers use about 2% of the overall energy. Unchecked, they will use 25% of the energy. People say the demand for compute is going through the roof, and that means 8 to 10 million new servers over the next couple of years, which end-to-end would be the length of Manhattan. I mean, we operate in communities, and I know you do too, where there's no more power. So we have to get to another place here, and I think the time is now. If we don't get on this, I think that there could be something quite catastrophic that happens as you've got a whole group of people who are craving the middle class, the opportunities for their children that simply the world can't deliver, and that creates instability, which I think creates a whole set of problems that you probably understand more deeply than even I do.
Meg, is there a danger, though, as I listen to all of you, of too much? My glasses are online, my watch is online, I got a pedometer in the heel of my shoe, I'm getting all this data. Yeah, I just want to cut it off. I mean, is there a danger that it just becomes too much for us to all handle?
Yeah.
Do you think about that?
So I think about that, and I don't know that I have the answer to it. So I wonder if we're wired for this. Yeah. I mean, if the human brain and our emotional state can actually sustain this. I mean, boy, I feel a lot more stressed than I did 10 years ago because I am always on. I wake up in the middle of the night, I reach over for my phone, and I check my email. This is probably not a good thing.
Yeah, absolutely. Yeah.
But it's like addictive. It's like crack.
Yeah.
And so I wonder what that means. But then I sort of end up feeling like, I remember when I was a young woman, I would sort of look at my grandmother and I'd say, oh, Nana, you know, she would say, I don't know how this, you know, she saw the invention of the airplane, the invention of the car, the invention of the PC, I mean, and she thought we were not going to be able to absorb it. And I remember thinking, oh, she's so old-fashioned. And so I hesitate to say this because I think the next generation is probably looking at me and, oh, she doesn't understand how you can completely process this all the time. But I worry about it, and I wonder what it's doing to sort of the psyche. But gosh, I think we're pretty adaptive. But I do worry about it. I don't know what you think.
Brian?
I think that we are absolutely wired for this. That I think our brains, if you think about the way the brain works and its ability to, you know, take in data at phenomenal rates, we're actually absolutely wired for this. When it doesn't work is back to a comment Satya made, is that we have to make this much more personal computing. When your watch sits on your wrist and it's cumbersome or difficult for you to get the data to move in and out, to understand how it operates, then that is not adding to your life, but actually your burden.
Right.
So it's our job, the three of us and our partners, to make this a much more personal event. And I think as an industry, we've figured this out over the last 5 years. We've figured out that that's a problem we have to do or solve. I don't think we're all great at it yet, but I think we all realize that we have to make this a more personal experience. When that is a personal experience, then all of those things add to your life. And they're smooth and they're seamless, and you'll appreciate them. You don't appreciate them when they're not seamless.
Interesting. Satya?
You know, it's very interesting. I was, you know, coming over to this studio to join this meeting, and my intelligent agent, so we have this thing called Cortana, which runs on our phones, and basically woke up and said, hey, the traffic's crawling, you may want to leave now. To me, being able to have something like that, we're all wired, but I don't want to be triaging my email, and now to add to it my Facebook feed and my SMS.
Yeah.
And, how can we have someone and computing actually help you? Because what's scarce, as I said, is attention. And to be able to, in the sea of data and sea of information, to be able to have someone help you, and that be your own computers, I think is the world that we need to get to in order to be able to deal with this. Because, you know, in its current form, it is inundating. But I think solutions have to come, and I think we definitely will break through.
Well, this is all well and good. It's been very interesting. But before I go, I just want to ask one question. What do you do for fun? Okay. How do you relax from all this? I mean, what are you reading? What are you doing to keep sane in a world where every day you're bombarded with blogs about you, news stories about you? You know, what are you doing to relax?
Well, I learned something very important when I ran for governor, and that is never to read what is written about you.
Very good. Just
and actually, I do, and I count on my team. If there's something I must see, I will see it, but I try not. We've got to just focus on doing the very best job we know how to do for customers, and there will always be people who have a point of view different than yours, and you got to play your own game. So that's the first thing. The second thing is I love to work, and what I love is the joy I get from the teams that I work with. I mean, it's great fun for me to go to work, and then outside work, obviously, you know. My family, my husband, we are hikers and river rafters, and we love the outdoors and the mountains, and you know, and then every morning I swim for an hour.
Wow, fantastic. Can you top that, Brian?
We already topped that one. You know, I think for me, it's I like to invent, and so if you've read much about what I do, I do a lot of the maker events. My daughters and I are, for example, this summer are going to build one of those balloons that we send up to the edge of space, weather balloons, right? But we're going to put an Intel tablet in there and see if we can get a 3D view of the world. So it's that kind of thing, that kind of invention and experiment that is fun for me.
You're telling me you just ordered something that your wife's going to be very excited.
Oh yeah, my wife's going to yell at me tomorrow night. My brand new CNC router will come tomorrow. That allows me to build the next big thing, right?
Right from your basement. Yes. Terrific. Satya, give us your weekend plans.
I don't know about, I'm a reader. I don't know whether I finish all the books I start, but I definitely try to buy a lot of books. The thing that I'm reading actually is the Thomas Pinckney book. It's a tome. At least I've taken the first steps. It's on my desk. And I'm also reading this great book, which is An Astronaut's Guide to Life on Earth by Chris Hadfield, which is just an awesome read in terms of what it takes to prepare for a lifetime for 5 minutes of real work, if you will. And the other thing that's changed my life has been these massively online courses.
Are you taking some now?
Oh yeah, I am. I'm taking this one computational neuroscience class, and the beauty of it is, I wish I had it when I was growing up, which is it sort of suits my attention span now. It's, you can take these for 5 minutes and take a quiz and have a sense of accomplishment. You don't have to sit through those 60-minute classes. But it's great. I mean, the best professors are available anytime on any subject, and what better time to go back to school than now? I'm
reading the book on the turnaround of Ford.
Oh, really?
Which actually I think is an inspiration to America.
Interesting.
And that is really, it's just remarkable what Alan Mulally has done with that company in partnership with Bill Ford, and that sort of marriage of the entrepreneur founding family with someone who brought that company back from the brink. It's inspiring.
I recently wrote a column in which I said there are 4 words that are going to disappear from the English language. And they are privacy, local, nothing stays local anymore, not this event, not anything else. Average, I'm afraid, is over because of all the things you all are inventing. We now have robots who milk cows in dairy farms in upstate New York. And later, because later was something when we were all young. You could swim this river, save this species, protect this forest. You could do it now, or you could do it later. But later will really be too late. Later will be when it's gone. Later is really over. And before we close, we're out of time, but just very quickly, what do you see as your environmental obligations now and concerns as companies? Because you're all touching this space. Meg?
So we think it's really important not only how we run our own operations and our own manufacturing and how we run our office buildings, but frankly, we think we have a role to play in creating the ability to save space and power that I think is essential to the future of the world.
Terrific. Brian?
Yeah, I'd say first on our products, our job is to more computing for less power, so that allows people to solve problems with less energy. A simple view is we want to have a large footprint but leave very small footsteps. And that's just a very simple model to give to the organization that says in everything we do, we should be leaving small footsteps in the communities we're in.
Satya?
I mean, it's, I think, well said, which is we've got to start with, we have the responsibility to get the product design right so that we have large footprint but small footsteps. But then I think for us, we also have to put our money on future sources of energy. In our case, we are betting in, for example, on wind as a source of energy for our data centers. So those are the kinds of forward-looking bets you have to make before they really come to fruition, because that's the kind of scarcity you've got to create for yourself to push yourself.
Well, I don't know about all you, but I've really enjoyed the Yalta of technology here, and I thank you all for coming, all right?
Thank you very much.
Thanks for having me.
Thank you, thank you, thank you.
I'm going to run.
Thank you.
Take
Great
care.
job, yeah.
That's really okay.
Thanks an awful lot. Virtual handshake to Satya.
Thank you. Thank you so much.
Great, thank you very much. So let me just, again, say thank you to Tom Friedman, thank you to Brian, and thank you to Satya for what a great discussion. And I think it's so important to really focus on partnerships as we take on the challenges that our industry is going to face. And I think you've heard us talk time and time again about what HP can mean to you. And if I can just leave you with one thought, we aim to be the very best technology partner for you on Earth. We are focused on defining the problem in your terms, defining the solutions in your terms, and showing up in a positive, solution-oriented way. So I just want to say thank you very much for joining us. We know you have busy lives. Thank you for spending the time at HP Discover. I hope you think HP is back. Thank you very much.